All right, this is lesson 4.2. I gave you all packets and I want you, it's the second paper in the packet. We just did 4.1 yesterday, so I made an announcement about it in class, but in case you forgot, it's two pieces of paper stapled together. The one that says Theorem 4.3, third angle theorem. If you flip that over, that is lesson 4.2, apply congruency in triangles. So I don't know if you want to unstaple it, but this is the side we're starting on. I apologize for that. There was an error with sending someone to the copier. That's just what happened. It's just what happened. All right. So first, let's just talk about congruent, what it means to be congruent. Two geometrical figures are congruent if they have exactly the same size and shape, okay? So here are three examples of things that are figures that are congruent, right? They have the same size and shape, they're just rotated. Then I have an example of things that are not congruent, right? Clearly they're not the same size. They are all triangles, but they're all different size. When two figures are congruent, the corresponding angles in the corresponding positions are congruent, and corresponding sides are congruent. All right, let's take a look here. So here we have, this is the image at the top of your notes, right? Lesson 4.2. We're going to identify the congruent angles and identify the congruent sides. So we use the marks on the angles to determine who's congruent, right? Angle A is congruent to angle P. Angle A is congruent to angle P. Sorry, my little swoopy got messed up. Because they both have one little mark here, right? One mark, they line up. Then I go to B, this has two marks. Angle B, and I look at my other figure, and I'm looking for two marks, and that is Q, right here. So angle B is congruent to angle Q. Last one, angle C has three marks, so that would be angle C is congruent to angle R. All right, those are all the angles. That's how we write those statements. Now when we're talking about sides, right, the side is a segment. There's one hash mark here in segment AB, so AB is congruent. We're looking for one hash mark right over here, QP. Go back to my original triangle here. BC has two hash marks, so segment BC is congruent to RQ. Last one, AC, three hash marks. That is congruent to RP. At this point, it doesn't 100% matter the order as long as you're matching up the right segments, but this statement matters tremendously to write a congruency statement. So I would say triangle A, B, C in that specific order. See how I went down here? A, B, C is congruent to triangle PQR. The angles and the sides will match up now for sure. Triangle P, Q, R. All right, now let's see if we can put this to work. All right, here I have a congruency statement. It says figure DEFG is congruent to KLMN. Here are my two figures, okay? So if I want to solve, first off, please note that they all have the same angle measure because they're congruent. So you can fill in things that are missing. G lines up with N, and that makes N, this expression, 6y plus 8 equal to G. So I can solve for y. Look at that. I was just going to fill in what I had missing, but I ended up making an equation. All right, and then I can solve for y pretty easy. We subtract 8, and I get 6y is equal to 76. Divide by 6, and I get y is equal to, and I know this is not a nice number, 12.6 repeating. And because it's a decimal, I'm actually going to get rid of that equal sign because it's kind of bad notation. And just make it a little squiggly, like it's approximately, you know? All right. Now back to where I was. Okay, so we did G. Let's look at F. F is in the same place as M. F is 68. We can put 68 right here. I'm going to keep going. E is in the same place as L. And I don't really know why I started going backwards. That was kind of weird. E and L are not given. Oh. Well, we'll have to figure that out another time. But we can say, we can fill out D. Yeah, later on we'll learn how to do that. We don't have to do that right now. D is 102. That means K is 102. All right. Oh, we need to find X and Y. So here's an expression with X. Side NM. NM is the last two letters in my statement. It's going to be equal to FG, the last two letters in my first figure, right? FG measures 12. So that means 2x minus 4 equals 12. Add 4, I get 2x equals 16. Divide by 2, and x is equal to 8. Fabulous! All right, let's look at some more things to learn. Things to learn. The third angle theorem. Please do not memorize these numbers, okay? And, you know, we used to use them, but every time they publish a new book, they change the numbers. It just gets confusing. So, and I know maybe I should stop writing them in there, but anyway. Third angle theorem. If two angles of one triangle are congruent to two angles of another, then the third is also congruent. We can go ahead and assume that, okay? If you see here, I have 1, 2, or 1 mark here, 1 mark here. That means this is 67. Okay, I have 2 marks here, I have 2 marks here. That means this is 54. Then remember, the triangle sum is always 180 degrees, so I can find the measure of angle C by simply taking 180 minus 54 and minus 67, and I get 59 degrees here. Right, that was 180 minus 54 minus 67 equals 59. Which is the same measure as angle F in the second triangle. So 4x minus 5 equals 59. If I add 5 to both sides, I get 4x equals 64. Divide by 4, and x is equal to 16. All right, that's not too bad. All right, let's check it out. Now we're going to go to the next page. Oh, that was the front page too. Sorry, guys. Sorry your stuff got stapled wrong. It's crazy. All right, so we're going to decide whether ABC is congruent to DEC. Okay, first, let us look and see what we have here. Clearly, all the sides are congruent, right? So all sides are congruent. I'm just going to use that, and that's given information. All right, so we know that. In order for them to be totally congruent, we need all the angles to be congruent. Okay, I see angle A is congruent to angle D. So angle A is congruent to angle D. I also see I have vertical angles here with C. I'm going to put 2 little hash marks here. They're clearly congruent. Angle C, sorry about that, is congruent to angle C. I'm just going to write vertical. All right, now I have two angles congruent to other two angles in the triangles. So we're going to use that third angle theorem. We can go ahead and say, we know it's a fact, son, that angle B is congruent to angle E. And we'll just use the third angle theorem. Oh my goodness, my pen is like not wanting to write. All right, so boom, we got all three angles, all three sides. We can go ahead and say, yes, these two triangles are congruent. Let's slap it together. Triangle A, B, C is congruent. Now we have to be careful how we name this triangle, right? If A is congruent to D up here, we're going to start with D. So it's going to be DCE. Make sure that your angles line up. Oh, look, and then I wrote the wrong letter. Silly goose. DCE. All right, beautiful. All right, we have one more example to look at here. Here we got another set of triangles. JKL is congruent to triangle PKL. Oh, I'm sorry. Please forgive me. I forgot to read the first word. Decide if they are. Well, let's start with our angles. We have angle K is congruent to angle K. Angle J is congruent to angle P. Angle L is congruent to angle L. Wow, that's riveting, right? Woohoo! Okay, so we got all the angles are congruent. So all angles, and that's given information. We did not have to use a theorem or something, right? This is given information. All right, so we also know some information about the sides, right? JK is congruent to PK, and JL is congruent to PL. We just need that third side. And I'm going to introduce a new term here, okay? This is called reflexive. Right? It's the same side. They share one side. Clearly, KL is going to be congruent to KL because it's the same line, same segment, I mean. KL is congruent to KL, and then we're just going to say reflexive. That's why. Reflexive. So now that we have all the sides are congruent and all the angles are congruent, we're going to go ahead and say, yes, this bad boy is congruent. So now we have all sides are congruent. All right, here's my statement. Let's put it together. What do we have here? We have a triangle, JKL, and we have to be real careful how we name it, okay, is congruent to triangle. So we went JKL, we're going to go PKL. Triangle, PKL. Yes, okay, that's my answer. Hallelujah. All right, let me know if you have any questions. All right, I'm here for you all the time, almost all the time. Between 11:30 and 6:30, I'm usually sleeping. But anyway. All right, here's your assignment for this evening or today, whatever. Assignment number 18, page 218. Numbers 3 to 16 and 19 and 20. All right, adios.